Alright, so here we are on part 2 of lesson 10-1, which involves the area of parallelograms and triangles. So let me do one more triangle example, just to kind of give you what other problems you may see on tests and such regarding the area of triangles. So it says the area of triangle GO is 40 meters squared, or 40 square meters. If the altitude GA is 8 meters, then find EO. So I always recommend draw a picture first. Okay, so I'm just going to sketch it. So I'm going to draw triangle GO. I have no idea if this is a right triangle, if this is a acute triangle or an obtuse triangle. But again, as I showed in part 1, it does not matter what kind it is, because you'll still get the same answer. So it says the altitude GA is 8. Okay, the altitude GA is 8. So let's draw that. We have G here. We need to draw the altitude from G, meaning going straight down, meaning it's going to meet at 90 degrees. So this here is point A. So this is the altitude, or the height, of our triangle because it meets at 90 degrees, and this is 8. Right? Well, since that's the height of the triangle, then this other side length, EO, must be the base. Right? So this is actually our base here. So EO is the base, which really means this is just a fancy way of saying if we know that the area is 40, and we also know that the area of a triangle is 1/2 BH, right? 1/2 base times height. Well, they give us the height, and we just need to find the base. So we can just say that 40 equals 1/2. The base we don't know, but the height we know is 8. I can now multiply the 1/2 and the 8 together, right? Commutative property says I can multiply those in any order I want. So you have 40 equals 4b, therefore b equals 10. And that would be your answer, right? Not too difficult of a problem. Just kind of, instead of saying base and height, they ask you just to find EO, and they use the word altitude, but you know what altitude means from previous chapters, and EO just naturally falls into place as the base. So the answer would be that EO equals 10, right? Side length EO is 10. Alright, let's move on to parallelograms. So we're going to find the area of a parallelogram. Now the parallelogram that's drawn here is a rectangle, and I want to show you the relationship between a rectangle and a parallelogram, because let's call this side length B. Let's call this side length H. And again, we know that the area of this rectangle is, you're probably going right where the Doseri thing is, isn't it? We know that the area of this rectangle is base times height, right? It's just base times height. Well, if I wanted to make a parallelogram out of this, let's say, I'll use a different color again so you can see what I'm doing. Let's say I wanted to, this is a quick way to make a parallelogram if you're ever curious. I can cut along this length here. I can cut that, which creates a right triangle that I'm removing, right? Imagine now that I'm cutting, well, let's go with the dimension. This is 2 units. The base is 2 units, and the height is, 1, 2, 3, 4, 6 units. So I'm going to cut that triangle, the triangle that's 2 by 6, it's a right triangle. I'm going to physically remove it. Okay, again, it's 6 by 2. I'm going to then paste it onto the other side. So from this side, I'm going to go over 2, right, because my original length was 2 there, and it's still up 6. This side length here is still up 6, which means I can now paste it on there, and I've just shifted it over, right? And you can see, you can measure or count the slope of this. These are parallel. We know that these are parallel. So we have a parallelogram. Now, what's the area of this parallelogram? Well, all I did was cut a piece of this rectangle off, right? I just cut this blue area off here, and I did what to it? Well, I just pasted it over here. So did I change the area from my original rectangle? No, because all I did was just move a piece of it, right? That's all I did was move a piece of it. So by doing that, I still end up with area equals base times height, right? All I'm doing is removing this piece, and I still have the same area. It just looks different. So the area of my parallelogram is just base times height. But remember, what does height mean? Height means that it meets at 90 degrees, right? So the height here is still the height of my original rectangle. It is not, I'll put this in red, it is not this slanted side length there. It's always going to be perpendicular to your base. Always perpendicular to the base. So if you want to write that down, it's a good idea. The height is always perpendicular to the base. Okay? So let's look at an example. It says find the area of parallelogram swag. So we know that it's a parallelogram. Let's S W A G. So we have parallelogram swag here. Now, what do we need to know? We need to know the base and the height, right? The area is base times height. Do we know any of those already? Well, we know one of them is the base. It doesn't really matter which one. Well, it kind of does in this case because it's going to be difficult to solve for the other one. But if I could, again, this is just a quick recap, I could call this side length here my base, which means this would be my height, or I could call this my base, which means this would be my height. Okay? I think it's easiest to do the first option because the angle measure here is going to come into play. So I'm going to call this my height. And what did that form? Again, height meets at 90 degrees, which means this formed a 45, 45, 90, which means we can now use the properties of a special right triangle to figure out the height here. Well, again, we know that the height times, or this side length of this 45, 45, 90, the side length, h, times rad 2 will give us the hypotenuse, right? H rad 2 will give us 5. So to solve for h, you just divide both sides by rad 2. So divide by rad 2, divide by rad 2, you get h equals 5 over rad 2. But we're not allowed to have a radical in the denominator, so you need to rationalize times rad 2 over rad 2, which gives us h equals 5 rad 2 over 2. So what does that tell you? It tells you, well, A, I can give you problems that aren't nice numbers, and B, sometimes the height is a little tricky to solve for. But are we done? We found the height. That's not what it's asking, right? It says find the area. So what do we now need to do? All we need to do now is plug this in. So we get the area equals base times height. The base meets the height at 90 degrees. The base and the height are perpendicular. So where is my base in this case? I can either view it as this number here, or this side length down here is also 10. So either way, one of these, either WA or SG, is going to be my base. So my base is 10. Alright, I'll do it in green. My base is 10. And what's my height? It's 5 rad 2 all over 2, because that's what we solve for. And when you multiply this, you can either cancel at the beginning, you can say this, these and these cancel to make 5 and 1, or you could have multiplied, if you don't want to do that, if you don't think that way, you can multiply this and get the area is 50, right, because this is like 10 over 1, so 50 rad 2 all over 2, which just gives you 25 rad 2. So if you can't see it, I think the thing's going to be in the way there, so I'll change. We get the area. The answer in this case would be 25 rad 2. Do we have any units given? No, we don't, so we write units squared, or square units. You always need to put units squared or square units. So again, this number, 25 rad 2, is not a nice number, right? But that's okay. You can still handle that because you're big kids, right? Or adults, depending on who's watching this. Or even a little kid. If you're a smart little kid, that's cool too. But you can handle radicals. It's okay. It's absolutely okay. Don't panic when you see a radical. Alright, let's look at another example. Find the height of a parallelogram with the area of 20 and a base of 5. So again, you don't even need to draw a picture here. This should be really straightforward. I just wanted to give another example for fun, for kicks and giggles. So, height of a parallelogram, area is 20, the base is 5. All you need to do, area is base times height, which we know. We can just substitute, right, 20 for the area, so 20 equals, well, we know that the base is 5, so we can say that 5h, therefore h equals 4 meters. And that's pretty much it there. I don't think I have another example here. We'll discuss more of these things in class. Yeah, that should be it. So have a splendid weekend, and I will see you in class on Tuesday. Alright, enjoy the 3-day weekend. Bye, guys.